Okay, so we looked at proportions yesterday. We even had like a little table where you pulled the proportions out and then solved it. Okay. The thing to remember about proportions is you want to be consistent. Okay, so if you're setting up a proportion for maybe miles per hour, if you put the miles on top for the first proportion and the hours on the bottom, then we want to make sure that in the second proportion we do miles per hour as well. So this is how you should do it. You want to make sure you don't do this. Miles over hours is equal to hours over miles. That is going to get you into trouble. Okay, so just make sure you're consistent when we're setting up our proportions. So that was our little note there before we got started. Now let's go ahead and try this out. So let's see that the ratio of hot dogs to hamburgers sold at a basketball game is 8-3. Okay. If there were 272 hot dogs sold, how many hamburgers were sold? Or how many hamburgers would you expect to be sold? Okay. So what we're going to do is we're going to set up equivalent ratios, a proportion basically, to help solve this. Looks like you guys are still writing. I'll give you just a second. Okay, so let's go ahead and set this up. So we are talking about hot dogs to hamburgers, okay? Now because it says hot dogs to hamburgers and the hot dogs is first, then we know that the hot dogs is referring to the 8. And this symbol right here can be read 2, just like that can be read as 2. Okay, so this is 8-3 is hot dogs to hamburgers. So when I write this as a ratio like this, we'll do 8/3. So here's our hot dogs. And here's our burgers. Okay. So now when you set up the second ratio, you just want to make sure that your hot dogs are on top, your burgers are on the bottom. Okay. Well, it tells us that 272 hot dogs were sold. So we're going to put our hot dogs on the top just like we did for the first ratio. And then we can just put a variable on the bottom to hold the place for our hamburgers since that is what we're solving for. So I'll put a little H there. Now once you have a proportion set up, you can multiply diagonally and divide and find out how many hamburgers were sold. So let me do that. All right, so that would be 3 times 272 divided by 8. And it looks like 102 hamburgers were sold. Okay, so H is equal to 102. Now I know I've said this before, but if your problem is in words, you should answer in words. The reason for that is I want you to be more than just a calculator. I know you can do calculations. I want to know that you know what that number means. Okay, so we're going to answer in a complete sentence. There were 102 hamburgers sold. Okay? And that way, you're basically interpreting your answer. You're saying, this is the number I got, and that's what that number means. Okay? Now, I want to show you something, just so that you're aware. It actually doesn't matter which one you have on top or the bottom when you're setting up a proportion, as long as you're consistent. So for instance, and I'm just going to do this in a, bless you, I'm going to do this in a different color so you can see. Let's do green, okay? If I had done the burgers on top and the hot dogs on the bottom, then it would have been 3/8. Now, again, just being consistent is the key here. If hot dogs are on the bottom for this ratio, then hot dogs should be on the bottom for this ratio. And then we would do our variable here to hold the place. Now, when I multiply diagonally and divide, the same things are happening, because look, you did 3 times 272 divided by 8. 3 times 272 divided by 8. So as long as you're consistent with which one you have on the top and which one you have on the bottom, it doesn't matter how you set up your ratios. Okay? See, look, I got 102 again. So I just wanted to show you that. Just a little offshoot of that example. Okay. Okay, let's try one more example. And then I'm going to give you some to practice. Okay. The fee to check luggage for an airline is based on weight. Okay, and then if Brett paid $7.14 to check a 42-pound bag, how much will Eileen pay if her bag is 63 pounds? Okay. So this time you're not given that, explicitly given the ratio, you kind of have to pull it out of the problem. So let's look back at the problem. Our first ratio is right here. It's $7.14 for a 42-pound bag. Okay. And then we want to figure out how much it would be for a 63-pound bag. So let's go ahead and set up that first ratio. And I know I've said it before, but generally money always goes on top. So we're going to do $7.14 over your 42-pound bag. So notice that I have money on the top, pounds on the bottom. So now, and this right here is Brett's bag. So we're kind of using that to establish our ratio there. Okay. Now we're gonna do Eileen's bag, or Elaine. I think it's Eileen. Okay. We don't know how much it's gonna cost. That's kind of what we're trying to figure out. So we'll call that C. But we know that the bag is 63 pounds. Okay. So I just made sure that my weight was on the bottom and my money was on the top for both ratios. And now it's all set up so we can cross multiply and divide. Pull out my calculator here. Okay, so $7.14 times 63 divided by 42. Okay, so we're getting that C is equal to 10 and 71/100ths, which is money, because that's what we're looking for. We're looking for the cost for the bag. Okay. And like I said, I want you to be more than a calculator, so we're going to answer this in a complete sentence. We can say Eileen's bag will cost $10.71 to check. And I don't know how many of you have flown before, but when you fly, your bigger bags get checked in before you get on your flight, and they get stored underneath the plane. And some airlines charge a fee for that, and some airlines don't. So that's kind of the context for that. Any questions so far? You're good? Okay. So let me give you just two problems to practice real quick. I'm going to throw one in there with fractions too, so that way we've at least seen one before you get to your homework. We've already done one with decimals, so we'll get a fraction one as well. All right. Okay, so Nick walked 3/4 of a mile in 12 minutes. How long would it take him to walk 3 miles at this pace? I'm sorry, that's not an example, that's your practice. Okay, so try that one, and while you're working on that one, I'll write another one underneath as well. try those two problems and we'll go on in just a minute. For that first one, I got this question. It's a good one. Can you change that fraction to a decimal? Yes, you can. Yes, you can. And that definitely makes it simpler when you're using a calculator. So that's what I'm going to do. I put miles over minutes, but if you put minutes over miles, you'll get the same answer. Okay. So 12 times 3 divided by 0.75 is 48. Is that what you guys got? Okay. So we could say it will take Nick 48 minutes to walk 3 miles. Okay. Any questions about that first one? Y'all are good? Okay, here I did gallons over liters, but if you did liters over gallons, like I said, you'll be fine. I used an L for my variable, and whenever you use an L for a variable, you want to use it as like a little cursive L because we don't want it to look like a number 1, okay? So I'm going to cross multiply and divide. Or I didn't even need to divide by 1. So we are getting that there's approximately 17.1 liters for 4.5 gallons. Is that what you guys got? Okay, great. Okay. All right, we got all of our answers in complete sentences so that we know what those numbers mean. And that's it for notes. So what we're going to be doing next, I'll show you the table of contents in just a minute, but I want to explain this first. Okay. You are given